Hello and welcome to Geospatial Programming. Today I'd like to talk about taking unstructured text, like Word or text documents, and turning them into something we can plot on a map. We'll be using simulated data from a company called Whitespace, who was nice enough to let me use their sample dataset. They embed analytic scenarios in their datasets, and if that's something that interests you, I'll link to them in the notes. The scenario we've been given is we have ankle monitor data for a person of interest, and we've been able to plot that on the map because it's just a CSV with coordinates. But we've also been given a whole folder of crime reports that are Word docs. And each one's got a coordinate in it and a date, and most of them have a time. So it'd be really nice if we could plot all of these Word docs on the same map. Now, unfortunately, these are spread across all these unstructured text files, so we'd either have to pull them out manually or use a tool. And of course, tools for something like this exist. But I think it's worth talking about sort of how to do this programmatically. And the way that we're going to do this is using something called regular expressions. And so if we knew exactly the phone number or the date that we were looking for in one of these text files, it's very easy to just use a regular text string search to try to find that. But if you have something like a date or a coordinate where you have a specific pattern, but you don't know exactly what the data that you're looking for is, we know that a coordinate has a pattern. It starts with, if you're in decimal degrees, 2 to 3 numbers, a period, and then some numbers after it, followed by something similar. And that can either be positive or negative. So we can take that information and use regular expressions, which is not Python specific. There's a regular expressions implementation in almost every programming language. We can do pattern matching. Now, regular expressions isn't something that I use very often, and so I kind of have to relearn it every time. But luckily, there are a number of online tools for building out your pattern. So let's go ahead and take this text that we've been given, just one of the examples here, and we'll build a pattern that we'll try to apply to all 85 documents. So I'm using Regex 101, but there are tons of tools just like this. And so we put our text down here, and then we start building our regular expression up in this regular expression box. And we're going to switch the flavor to Python, and all that really does is change our decorating text around the outside to tell it we want a literal string. And so let's start with something somewhat simple like these dates. And down here on the lower right, they've got a quick reference. So dates tend to start with 1 to 2 numbers, so we can kind of start building that out. So we can take any digit. They've got this really nice common token for any digit, where if you click on it, it tells you what the actual character is, as well as what that's equivalent to. And in regular expressions, you can give it like a range, so in brackets. So this would be 0 to 9. So a /d will tell it to find just one digit. You see all these highlight as you put that in, so that will start helping us identify when we actually get matches. And so if we're doing month, day, year, we want maybe 1 to 2 of those. And so they have some examples here in the lower right about how to tell it how many you might need. So in this example, they've got between 3 and 6 of something. So you have the thing you want, and then curly brackets, and the 2 numbers. So if we want between 1 and 2, we just kind of do that. And we can see that it's starting to highlight some of these pairs. Next, we want a slash. And a slash means something specific in regular expressions. So if we give it a different slash in front of it, it will make it a literal. And then we're just going to want this part again. It's possible the forward slash actually doesn't mean anything, so we can probably leave that alone. Cool. And as it continues highlighting, we see that we're getting month day. And then we probably want it to start with a literal 20, but if you're trying to get any year, then we can kind of do the same. So that matches our year. And what we've come up with is perhaps a little bit permissive. For instance, it will allow any digit here. So if our example was, if we're in the 65th month, it will still accept that and try to find it. So you can keep making these more specific. So for instance, you could only allow it to take 0, 1, or 2 as the first digit, and then 0 through 9 as the second digit. So you can start to get more specific here. And it's kind of a balancing act between making this far too complicated versus making it too permissive. All right, so let's take a look at, now that we've got something that can kind of match most dates, especially if they don't have anything similar to this pattern-wise in other files that are non-dates, we can use this as our date pattern, and we can start building out our coordinate pattern. So we see that these tend to start with a parentheses. We've got our latitude, and then a comma, and of course there can be a positive or negative in front of this. In this case, because we're in Baltimore, there won't be, but we can try to design our pattern to look for that. And then our longitude. So parentheses actually do mean something in regular expressions. So we do have to say that this is a literal parenthesis that we're looking for. And then if we give it a negative, we see we no longer have any hits because our coordinate doesn't start with that. But I'm not sure if it's under common tokens here. Here we go, 0 or 1 of something. So you can use the question mark to say this may or may not exist. So if you find it, great, and if you don't find it, also great. And so we might be making this a little bit too permissive. You can specify the exact range here, but we can kind of just do something similar to what we did before. Any digit, 1 or 2 of them, and we'll get our beginning of our latitude. We'll want a literal period. A period also means something in regular expressions. Again, not sure if it's in the common tokens here, but I believe it means, yeah, any single character. So if you just put a period, if we change this to just a period, and this was an A, it would also accept that, but that's not what we want. We want the literal character period. So we'll change that back. And then grab some number of numbers after that. So we want at least 1, maybe not more than 10. So that grabs our first number there. Then a literal comma and a space, which it grabs. And then we want to start grabbing our longitude. And so latitude goes from -90 to 90, so longitude will want it to go a little bit wider. So we will kind of do something similar. The negative, in this case we've got it, but we'll make it optional. Any digit, 1 to 3 of them, a literal period, and then we'll copy that part. And then a literal closing parentheses. So this is a pattern that we can use for grabbing our coordinate. And this should work for all of our files. The last thing we want to do is, if there is a time, grab it. That way we can join it with the date to make a date time if it's available. So I'll get rid of that. So making a time pattern. So again, we want any digit, 1 or 2 of them, literal colon, definitely 2 digits, so we can either do /d/d, or just in curly brackets a 2, a space. And then this is where regular expressions starts to get complicated. You can tell it AM or PM. So it'll try to find AM or PM after what we've got here. And this is in something called a group. So you use the parentheses. In this case, we don't want literal parentheses. This is a concept in regular expressions. And I don't want to go too far into how to build complicated queries, but you say this has a alternate match either A or B. Well, in this case, we've got multiple letters that we want to match. So we'll put these in a group, AM or PM. So this works in this case. If we had BM, no joy, PM, and it'll match that as well. Right, so this is the patterns that we've built, but how do we actually use that to find all of these matches in the 85 text documents that we've got? And building these patterns, again, can get very complicated, but I think the important thing to take away is that if you've got something that has a consistent pattern that you can define, like an email or a phone number, or in this case, coordinates, addresses can be done as well. We've been working with numbers, but of course, you can do letters. So in this common token in the lower right, they've got any character in the range A to Z, as well as lower or uppercase. So you can do text. Anything that you can build a pattern around, you can use regular expressions to search for. And I think that's the main takeaway. There's no need right now, if this is something that interests you, to start memorizing all these tokens. They've got these very nice references to help build these out. There are, of course, tons of questions on Stack Overflow if you've got something pretty niche that you're looking for, if you're having trouble building your expression. And typically, when you're building an expression, you really only have to build it once. And then you can apply it to all the things that you're trying to solve. All right, so let's switch over to code. So we've got our patterns, and I'll copy them into here in a little bit, but we need to import a couple libraries. So the regular expression library in Python is just RE. We've got a folder of 85 documents, so I'm going to use the glob library to identify them all. And they are in Word doc format, so I'm going to need a library called docx to read them. So we'll start by implementing our document reader function. So let's start by identifying the files. And they're in a folder called crime reports. And we give it our glob pattern to find anything that ends in docx. Just to make sure that worked, we can see the length of that list. I guess we've only got 84 files in there. There must be something that's not a Word doc in here. Yep, there's a CSV at the bottom, which looks like exactly what we're trying to recreate, so that's awesome. Okay, so we've got our 84 file paths, and now to read text from them. So we can use the docx library to create a document of our, let's say it's the first file. Let's make that a variable, so this will be easy to turn to a function. We have this docx document, and you can request the paragraphs from it. We don't care about any sort of formatting that's in this file. We really just care about the text itself. So we're just going to loop through and grab all these. So there are 3 paragraphs. If we grab the first one, we can grab the text from it. And we'll just want to do that for each paragraph that we find in here. So I'm going to use list comprehensions and string joins to turn this into a single chunk of text. So we're going to want to separate these by a line break. And if you're not familiar with list comprehensions, I wouldn't worry about this too much. This is all just getting us to being able to read in these Word docs. You can, of course, just make a for loop over these paragraphs and grab the text and then join them together. But we'd run this, we get a single string that we can run our regular expressions against. All right, so I'm just going to turn this into a function so that we can just reuse this 84 different times. It's going to take in a file path, we'll open it, and then we'll return the joined text, all the text we find in that document. Right, and for testing, we'll get all the text from that first file. Right, so now we can start making our patterns. And so I'll just kind of copy in ones that I'd made before, but our coordinate pattern, our date pattern, and our time pattern. And we run something called regular expressions.compile. So now these are not just our patterns, but they are a compiled version of those. So let's run this and take a look at those. So this is something in the regular expressions library. And so now we can use the find all function on the text we've got here. So if we've got our coordinate pattern object, we've got the find all, we give it our text, it will give us a list back of every coordinate that it finds in that text. And so we can do the same thing for our date pattern, and we can do the same thing for our time pattern. And it's worth noting, you might see this done a little bit differently depending on what example you're looking at. There's actually a few ways to get at this. You don't necessarily have to compile. You can use the text directly. And there's other functions behind besides find all. One of which is search. So if we use regular expressions.search, we can give it the time pattern as well as the text. And it gives us back these match objects, which if you run a group on, the group function on, it gives you back the text. For what we're doing, I think it makes a lot of sense to just use find all. There's a little bit less work. You don't have to worry about understanding what groups do. Getting back a list of text is quite nice. And because these Word docs are pretty consistently formatted, we don't have to worry about there being multiple coordinates or multiple dates or multiple times. We can just grab the first one. So let's go ahead and start pulling out the information that we're going to need before we turn this into a for loop. So the coordinate that we're going to use, we'll just grab the 0th thing out of this find all results. So our coordinate is now this nice string. Our date, we'll do the same thing. We'll just grab that first element. Now we've got a date. And for our time, we'll do the same thing. And not all of these have a time. So we'll actually build that in. So it'll be nothing if the length of that time is 0. Otherwise, we'll grab the first thing in that list. Cool. So in this case, it's PM. And we also want to grab the actual latitude and longitude out of this. So in this case, we'll get rid of the parentheses by slicing 1 to -1, and then split on the space and comma, And then we'll have a lat and long. And note here that they're both still text. So we'll have to convert these into floats before we start doing anything with them. Okay, so now we can go ahead and just turn all of this into a for loop. So we can indent it. We can say for file files. We want to get the text. And now we can grab our variables directly. So we'll get our chord for each file, split that into lat and long, get our date, get our time. And we'll also want to save these off. So we'll make a results list. And we'll create a dictionary for each row. So our latitude key will convert lat to float. For longitude, we'll convert lon to float. For our date time group, we'll take the date, add a space in there, and get the time. And then we might as well just include the whole text. If we turn this into a shapefile or something like that, it couldn't hurt to have that as a reference. Or you could also just put maybe the file name if you wanted to be able to reference it. User's choice at that point. All right, so we'll append this result to our results list. And barring syntax errors, we should just be able to run this. All right, so now this results is a list of our results. Our latitude and longitudes are numeric. Our date time is text. Oh, but I see that that just has PM, so we made an error there. Ah, okay. So I did find all, and I mentioned that regular expressions has this group concept, and what it's finding is just the group. So what we actually need to do is use the re.search, which will grab the whole group. If we use the group function, then it gives us the whole text. All right, so I'll swap that out here. So now we'll use re.search. And instead of checking for length of 0, we'll just find if it's none or not. And otherwise, we'll use the group function. All right, let's try this again. Okay, so now our date time group is an actual date time group with the date, time, and then AM or PM. All right, so once you have a list of dictionaries like this, we can turn this into a geodata frame. So let's go ahead and import pandas and geopandas. We'll make a data frame first. I want to call that df instead. And so now we've got this really nicely formatted data frame. And we can, of course, because we've got a lat and a long, turn this into a geodata frame. And I believe this example going from a data frame to a geodata frame is just on the Geopandas website. All right, so now we've got a bunch of points that we can plot on the map. So first, let's make this to file. now we've got a crime report shapefile, and we can drag that directly into whatever GIS you use. Turn off the OpenStreetMaps layer so you can see it looks like a few of them coincide pretty directly with the ankle monitor coordinates that we have, but of course, correlating that in space and time would be necessary to figure that out, which we do in the Moving Pandas video that I posted a little while ago. So regular expressions are a very powerful way of going from something that is text that you expect or know to have a pattern that you can find a way to codify in a regular expression pattern. And so in this case, because we had pretty consistently formatted text files, we were able to go ahead and do this. I believe Arc has a similar capability. I don't know if they brought LocateXT in, or that also is a program you can use. But if you have something else you're looking for, or maybe you don't have an Arc license, being able to do this yourself is pretty powerful, especially if it's a unique coordinate system that you can search for, or something that's going to be coming down consistently that you're going to need to run daily and want it to be automated. This is a pretty powerful tool. And in this case, we were able to find the date time as well, so we could certainly turn that into a date time group and run our matching accordingly. So hopefully you found this useful. Regular expressions is incredibly powerful, but it's not for everyday use. Having to memorize all of the capabilities that it has, some people definitely have, and I am not one of them. But I do have a general grasp of what it's able to do, and I think that's enough to be able to get you reasonably far. A big thank you to Whitespace for letting me use their data in these videos. It's hard to get co-collected data, especially with fun scenarios in them. And so having things like the GPS coordinates and these crime reports, and they've got license plate reader data and telecommunications data, all built in here, as well as a bunch of base files about buildings and laydown of their simulated sensors, tax and vehicle registration. It's all very cool. So thank you to them, and hopefully you find this interesting. If you did, please consider liking and subscribe. Thank you very much.